I'm just gonna hit the record button. But yeah, so yeah, welcome back to uni, by the way. So yeah, you guys just had your break, and I hope that you guys get settled in again to the group of the uni. Probably most of you guys are third or fourth years doing civil or environmental engineering and whatever. Yeah, I think your third year or your fourth year is where you really start to find what you're interested in terms of all the various disciplines in engineering. So I hope that this course can kind of open your eyes to what's out there. I really enjoyed this course when I was doing it because the style of workshop, like how they're run, is very different, right? So what you'll find is that these workshops are a lot more interactive. Like I'm going to be coming around talking to you guys, asking you guys if you have any questions. You guys will be collaborating with the people on your table to try to do and figure out the workshops for the first few weeks. So the first 4 weeks, yeah, is basically there's like a homework component, like this pre-work or whatever, and then you come into class and you get participation marks. I'm not terribly strict, to be honest, with marking. If I've seen that you've given it a good go, I'll give you the mark. But yeah, I'll be coming around twice to mark those things respectively. So with that said, if you haven't like opened up in the middle or whatever yet, it's fine. But you should go and try to do the pre-work so that I can tick it off. But yeah, the other thing about how I like to run these is I like to do like a little bit of like a mini lecture recap on the content like each week, just to make sure you guys are like up to date with all the information. And I'll even do like a quiz thing, like a little interactive quiz in the middle, and then we'll get onto the actual workshop stuff. So yeah, first I'll go over the course and how it's run. Assessments, right? So like I mentioned, the workshops are assessed, you get like participation marks, and the whole thing's 5%. There's 4 geology workshops, so for the first 4 weeks, you know, you do this whole like participation thing. So each week is 1.25 marks that you can get for free. And you get 0.625 and 0.265 for doing the pre-work and the work in the class. Okay, so that's how it works. The other thing to mention is the assignment. So let's talk about that first. If you haven't formed a group yet, I think the groups are 5, unless I'm mistaken. Yeah, there's groups of 5, and then you get like a part A and a part B of your assignment. So part A is a poster. So Kurt will give you more information about that when it comes out, but like there'll be a poster that you're doing where you choose somewhere in the world to research on and you put together a poster as a group. Okay. So for example, like Grand Canyon or whatever, right? Just like you talk about the geology of it. And the other thing is part B. Part B of the assignment is, struggling to remember. Oh, it's like a site investigation, right? So you basically go as a team to Bronte Beach or Coogee Beach, and you map out a bunch of defects in the rocks in those like kind of coastal areas. So you'll find like little joints and cracks and things in the rocks, and then you basically make a report on the site. Okay, so this is kind of like a practical component, and they want you to like essentially do field work, right? So it's like supposed to simulate what it'd be like working in the industry, and then this would be like a shitty intern task that you're given or something, right? Yeah, does that make sense to everyone? Okay, so that's the assignment. The next thing is the geology quiz, right? So the first half of the course, as I mentioned, is geology, and you'll be tested on it, right? So this is like the midterm, and this year it's in week 7 Thursday, which is a little bit unusual because normally it's in week 5. And so I find it a little bit weird because I think people will still be focusing on the geology part of the course, like the first half of the course, as they're coming to the week 7 workshop. So I'm gonna have to figure out what I'm gonna do in week 7 just to try to benefit everyone. But yeah, so that's the midterm. Does that make sense to everyone? And then there's also the finals. So the finals will only be based on the second half of the course. It's only based on the geotechnical design part, right? Okay, does anyone have any questions about how the assessments and whatever are gonna work? Yeah, okay, cool, let's move on. We've got a lot to get through today, so I'm gonna try to get through as much as I can, and hopefully it doesn't feel too rushed. So here's the layout of the course. Again, as I mentioned, there's a geology half, which is the first bit, and then there's also a applied geotech design part, right? So in the first half, you're gonna be learning about like plate tectonics, like how the Earth was formed, how the rocks moved around, and whatever. You'll be learning about the rock cycle, the different types of rocks, structural geology, types of soils, and how to do site investigations, basically. So that's the first half. Second half is, it's basically more structural. You're focusing on like the footings and the foundations of buildings and retaining walls and things like that. So it's the interface between structural engineering and geology, or geotech design. Okay, are we clear on all those things? I'll get more into the second half as we go later in the term. Okay. All right, cool. Okay, so I'll just quickly talk about this. Like, in terms of the course outcomes, it's a little bit different to your other courses because a lot of them are focusing on primarily your technical skills, right? Like how well you can crunch the numbers, how well you can do the maths and physics, and then you pass the finals, and that's the end of the day. This one will incorporate more practical skills, so that's what the assignment's trying to, bring in. It's like a little bit of what do geotech engineers do in the field, what do they do in industry, things like that. And a little bit of a research component, so you can get your head wrapped around how they, again, like do this in academia and whatever. I don't know if it's changed, but I think if you get a HD in this course, Kurt also refers you to PSM or something like that. So yeah, lock in, you know what I'm saying? All right. Okay. So next thing is, well, the first thing I should say is geological time. Right. So when we're talking about like the formation of rocks and Earth, usually we have to like talk about millennia, or millions of years ago. And so it's good to catalog everything in terms of these kind of units, right? So MA, KA for mega annum, kilo annum, whatever. And you get an idea of basically like how these layers of rock were formed. Older rock was formed earlier, right? So the stuff underneath, it's generally denser, it's generally older, and then the layers above that are the newer layers of rock, essentially, right? And yeah, that's pretty much all there is to say about that. There's a bunch of these diagrams on the Moodle, and like you can Google them. But yeah, those are all the different time periods and stuff. Next thing is the different types of rocks, right? So we've got sedimentary rock, metamorphic rock, and igneous rock. Now, a lot of you guys would have touched on this briefly in, like high school geology, high school science. Essentially, it's a cycle, right? So they become one another based on various conditions like erosion, lithification, heat and pressure, right? That's the general idea. And it's also important to note that rocks are made up of minerals, right? So that's the hierarchy. And then minerals can be made up of chemical compounds, okay? So rocks are basically just like arrangements of these minerals and then arrangements of these chemical compounds, right? Okay, yep. Essentially the rock cycle is driven by Earth movement, right? And we're going to talk about tectonic plates in a second, but like the Earth is broken up into these tectonic plates and they move around. And all this energy stems from the interior of the Earth, which, is is the energy source for this Earth movement, basically, right? Okay. I think this is a pretty nice graph here, pretty simple graph of how the rocks can become each other with like different arrows in the process and stuff like that. And there's also, not only are there like different types of rocks here, it shows you like its interaction with magma and sediments, right? So there's a kind of like in-between steps as well for forming rocks. So for example, an igneous rock can break down due to weathering and erosion, and then it becomes a sediment, right? That sediment can get compacted, right? And then become a sedimentary rock, let's say, okay? And then if a sedimentary rock is exposed to heat and pressure, right, from like, say, like a source of lava or whatever, it can become a metamorphic rock on contact, right? And then, that can basically melt down further due to further heat and pressure and become magma. And once that cools down, that becomes an igneous rock, and then so on and so forth. You got these interactions happening over a long period of time all over the Earth, right? Okay, make sense? All right. So, yeah, the Earth is broken up into these different layers, right? You got the inner core, outer core, and the mantle is like basically the description for a bunch of these outer layers, right? So we've got like the asthenosphere, the lithosphere. Yeah, you'll just be hearing these terms, and that's kind of like that's that thing I was mentioning with like the energy that's driving all this like Earth movement and stuff like that. It's from the mantle. Okay. Yeah, you have all these different plates that the world's broken up into, and these are called tectonic plates, right? So you got some which are continental plates, and you got some which are oceanic plates, right? And basically the rule is that continental plates are lighter, and oceanic plates are heavier, and it's because of their mineral composition, right, that you generally find within them. So mafic minerals like basalt, for example, are heavier, and that's what causes like oceanic plates to be heavier. And then you get a bunch of interactions between the boundaries of these things, right? So there's three types: convergent, divergent, and transform boundaries, let's call them. So the idea is convergent boundaries is when you have two boundaries and they're like hitting against each other, or like the Earth movement's driving them towards each other. Divergent is when it's splitting apart, so these two plates are coming apart. And transform boundaries is where there's like a shear interface between them and then they're sliding past each other, like that, right? So that's the kind of interactions that you get with these different plates. So, yeah, I mean, these are just more specific examples of those interactions, but you can break them down into, so if you have two continental plates, right, and they're diverging from each other. So remember, continental plates is like no water, like as in like two bits of Earth, right, and they're drifting apart from each other. That creates a rift, right? So that's the term that you're going to be using to describe that. Oceanic plates is where you have two oceanic plates, and then they're like coming apart from each other, and then water's like basically filling in that gap, and then that creates a ridge. And then for convergent boundaries, you have two continental plates clashing against each other, and essentially it wants to form a mountain because it wants to buckle upwards. It can't go downwards, so the Earth has to go up like that, right? Okay, and that's what creates mountain ranges. And then when two oceanic plates are clashing against each other, one will start to get destroyed by the other one, right? They break, they disintegrate. And then something that comes up in the midterm every now and then is Kurt wants you to describe the interaction between a continental plate and an oceanic plate when it converges, because this scenario is like pretty nuanced and there's like a few interactions going on between it. But essentially, the oceanic plate is made up of the heavier minerals, and so it gets subducted, right? So you get the oceanic plate and your continental plate, and they're clashing against each other. One starts to go underneath the other one, and it's the heavier one goes underneath, right? And it forms something called a trench, right? And also a mountain range off the edge of the continental plate. So that's what's happening. It's called a trench. Yeah, trench. That's basically what's happening here, here, and here, right? So that's like a pretty complex interaction, and it's sometimes like quizzed in that midterm. Okay. For transform boundaries or conservative boundaries, that's when you have that shear interface between like two plates. And if you imagine the plates as having rough edges and then they're shearing against each other like that, essentially there's bits of material that get caught up against each other, and then stresses develop, and essentially it's all released at once in the form of an earthquake. So that's how you start getting earthquakes around the world. Yeah. Okay, any questions with that? So yeah, those are all the different types of interactions that you'll see between the boundaries. Okay. Another thing is that, yeah, I made like a little Excel chart. So this is like documenting all the midterm topics that are seen in like the practice papers, right? So from 2012 to 2019, the midterm generally had 6 questions, and yeah, question 1 was always defects, which happens in week 4. Sorry, that we dive into in week 4. And then question 2 can be a mix, generally structural geology. Question 3 could be all kinds of things, but often you see tectonic plates come up. Question 4 can be all sorts of things, generally soils. Question 5, generally minerals, and question 6, and sometimes question 4, geological profiles. So geological profiles are just like a cross-section of a site, for example, and it's pretty common because it's just an application of everything that you've learned. It's like, in this given scenario, what would the cross-section of the land look like, or whatever, right? And it's kind of it's like a skill that you're developing over the next few weeks in these workshops, basically. Okay, any questions? No? Okay, fantastic. For the people who can be late, you can scan this QR code, and it's my notes, so yeah, maybe that's useful to you. So what I'm going to do next, right, I'm going to freeze the screen, so you can scan that if you want, but I'm going to pull up a quiz, right? So if you get out your phone, there'll be another QR code in a second. Oh shit, wait, 1 second. Okay, they've changed this website a bit. It used to be called Quizzes, now it's called Wayground. So if you scan that QR code, we're going to do a quick quiz about what I just talked about, and then we'll get on to the actual workshop. All right, so if you join that, I don't know. I like these weekly quizzes because there's no stakes, you know. I'm not going to like fail you if you get 0 on this or something. But it is good because if you learn a little bit every week, it's going to make the midterm a lot less like daunting when you actually get around to doing it. Okay. All right. Give it like 10 seconds. You can keep joining if you want. Okay. All right, is anyone still joining? All right, I'm gonna start. All right, good luck. Have fun. Oh. Let's do the elevator music. All right, is anyone still going? All right, most of you guys are done. I'll give you like 10 seconds to finish if you haven't finished. All right, 5, 4, 3, 2, 1. Come on, guys. One more. right. Excellent. Okay. Let's see what. Oh, okay. Hard, Liam, PJ. Congratulations. All right, you guys got full marks this week. No, I'm kidding. All right, so. All right. Yeah, we did a good job. Good one. All right. So let's review the questions. Okay. All right. So yeah, I forgot to tell you this. So surprise. Sedimentary rock. Sandstone's a sedimentary rock. So why are the other ones wrong? So quartz is a type of mineral. Quartzite is a metamorphosized version of sandstone, right? So it's a metamorphic rock. Sand is a type of soil. Yeah, and sandstone's the only sedimentary rock here. Okay. Next one's shale. So shale is a sedimentary rock. Slate is a metamorphosized version of shale, so that's a metamorphic rock. Clay is a type of soil, and silt is a type of soil, right? Okay, what's a real life example of a convergent plate boundary? So the Himalayas is like a mountain range, right? And it's where you get the two continental plates clashing against each other. Mid-ocean ridge is not right, and then shield volcanoes. I don't know, I made this 2 years ago. And then Bermuda Triangle is like some other shit. Okay, so when an oceanic plate converges with a continental plate, oh yeah, this is the subducted thing. So the oceanic plate is heavier, so it goes under. Yeah. Okay, and yeah, I'll show you rocks. Okay. I'm not sure if a diamond's a rock, I'm not gonna lie. Okay. Yeah, thank you guys for your contribution. Oh, that's me. Okay. All right. Okay. All right. So yeah, I'm gonna start recording now.